Hello everyone. Welcome to the Out of the Box Developer. Today we have an amazing guest, but before bringing him, hello Chila, how are you?
I am fine, Thiago. Hello everyone, and I'm very happy to be here today and learning more about Java in connection with big data and data engineering. So I'm sure it will be a very interesting conversation.
Yeah, I do agree. And keep going. Hello Luis, how are you?
Hello, I'm finding you. I'm very happy to be here and welcome everyone here. Today we have a special guest, as Thiago said, and I think this topic is very great. So uh, keep up with us here, and hope you have a great session.
Yeah. And keep going. Hello Igor, how are you?
Hi, Thiago. Hi, Chila. Hi, Luis. Hi, Hugo. Hi, everyone. For you that are watching us. Yeah, today we have a special guest. He's my shout out or namesake, how I believe it's said in English. It would be great to see a little bit about that. I've worked with big data a very long time ago for a mobile company, so it will be interesting to see how things are on today.
Yeah,
That's it.
and not only for people that work with the data engineering, but I think also developers and other roles also need to know a little bit about that. So it will be a great talk. And last
Absolutely.
but not least, hello Hugo, how are you?
Hey, Thiago. Thank you, man. Yeah, I'm great. Well, last minute meetings and yeah, but got to get here almost on the time. And I'm looking forward with this discussion today. Java with modern data engineering, man, that's powerful. I really would like to see what we have these days, and I touch a lot with data science projects. We usually have some data engineering pipelines, and it's always incredible to see the challenges and all the scale challenges and every tools that we have. And Java have a lot of things on this ecosystem, and that's amazing to discuss about. So I'm really looking forward. Uh, but yeah, let's go, Thiago. Keep going.
Yeah, it will be an amazing conversation. And our guest, he talks a lot about data engineering. He's an author, he has his own blog. We can share here, have amazing content there. He also helps a lot community. He talks a lot about that topics in history. We can also share here. And not only that, but he's also an international speaker. He gave a talk at the Vox and also on some jugs, including the Lisbon jug, which I had the opportunity to give a talk at the same day with him. So it was amazing. And I bring here Igor Souza. How are you?
Hey, hello, hi guys, how's it going? Yeah, it's a pleasure to be here. Thanks for having me. Thanks for the invitation. Yeah,
The pleasure it's me and also from my
I don't
colleagues.
think I'm
Pleasure
a
it's
new face on Soul Java, right? Yeah, I've been here several times already. I was saying.
yes,
So
yes. If you are watching us and
hello for everybody who's watching.
if you know him, you can put on the chat. If not, please put on the chat where are you from. It will be nice because here you have people from all over the world. So Igor, it's talking from Dublin, right?
Yes.
And maybe Igor, you can, I don't know, share a little bit about your career path, and then we can go to this amazing thing and talk a little bit about these new tools, this new release of Kafka and many other stuff.
Yeah, yeah. So my name is Igor Souza. I've been working with Java. I don't know, more than 20 years each. Being old already. So I moved to Ireland almost 15 years ago, and by lucky I got in a company that was big data ish. It was starting with Hadoop. Back in 2012-ish was when the Hadoop became really popular and loads of people start using. I was kind of the top of the curve, right? Doing lots of things in Hadoop and things like that. So then my background is development. I always work as developer. But back then I started being more involved in data engineer stuff. Since I don't think the data engineer term was used back there, but still. And then I think it was 15 or 16-ish. Then I started with Kafka. And since then, I kind of became... I usually to say I'm Kafka specialist, right? But I don't think there is such a thing like that. But still, Kafka is one of the main things that my areas of interest, right? And then I do lots of blogging. I did several talks worldwide. As you said, I've been in Devoxx, Belgium, UK. There's a big data conference as well. I've been several times. Anyway, those are the things. And I work as a software. I used to joke, right? I'm a software engineer in a data engineer team. So I kind of mix borders there. So there's lots of overlap. Of course, as a developer background, I try to focus or I try to look more developer things. But I do lots of data engineer stuff. And for hobby, I play with hardware. So though I do a lot of hardware stuff. I try to automate my home and this kind of things. Make it. So I in my blog, I mix data engineer stuff and Java with Raspberry Pi, or I try to use the Java on microcontrollers, those kind of things, right? But anyway, data engineer is the area that I work with, right? Loads of tools around. And again, if we are going to talk only about Kafka, is a word without end, right? Imagine a big data, Hadoop, Hive, there's thousands of tools. There is a famous, I don't know when they started that. I think it's 4, maybe 7 years ago. There is a kind of, I forget the name that they call, it's the landscape. So if you search on Google, data engineer landscape, you're going to find for 2017, 18, 19, 20. And then the picture is loads of products, right? There is hundreds, thousands of products. And then the joke is like it's quite impossible to know and understand all hundreds of products, right? Hundreds of frameworks. And then they split those frameworks like data pipeline, data orchestration, ingestion, streaming, batching, micro. But anyway, there is billions, like thousands of things to look. So it's just navigate through those things and figure out some of them. It's funny because Java 24 was released last Tuesday. And then Oracle did 3 days of live streams. And I think it was on the first day, they invited people from Microsoft, from Uber or Netflix. I think if I'm not mistaken, the guy from Netflix, he was like, no, we are celebrating Java because here everything is Java. We use Apache Peanuts, we use Kafka, we use Flink, and we use, I don't remember what, but he said like 4 or 5 data pipeline tools, all based on Java, and that everything is Java, JVM-ish based. It was funny to see. So I'm not the only one.
And not only Java, but also Kafka, right?
Yeah.
So Kafka released a new version, and it's a major version, right?
Yeah, so it was in the same day, Tuesday, last Tuesday, right? 23 or 24 of March? No, it was last week, right? Today is Tuesday, yeah, a week ago.
Last week, yes. I think.
And then was Java 24, Kafka 4.0, that brings lots of things. For example, one of the new things on Kafka is the queue, the ability to use as a queue mechanism, because Kafka is streaming. That's one of the famous misconception about streaming and queue. They overlap a little bit, but they are completely 2 different things. So now to make the things more complex or more complicated, the stream platform Kafka has the ability to be used as a queue. But there is the RabbitMQ. I think it's one famous framework from message queue. You can use with Stream as well. So that it's
You
perfect to make
mentioned
everybody confused. Yeah.
you mentioned the RabbitMQ I used earlier, and you also mentioned the Hadoop. Back on that time, I've been working with Hadoop as well, but from what I could see, you continued working with Hadoop and then evolved to Kafka, right? And
Yes.
I kind of moved back to software development because customer requirement changes, change customer and all that stuff.
Yeah. Anyway, Kafka, Hadoop was really trained in maybe 10, 15 years ago, 10 years ago ish. And then
Is
became
it alive yet?
Yeah, it's still live. There is loads of things that makes people give up Hadoop, but big players or people that invest a lot of money in Hadoop, they still using, right? So there is still big customers. There is, I think, the biggest telecom in Europe. It's a heavy user of Hadoop, and they are never going to stop using because they already spent billions of money in infrastructure and configuration and things like that. And then companies like Hortonworks that was acquired by Cloudera and Databricks, and then they still there and they still providing Hadoop solutions and things like that. It's open source project. You can contribute there.
I'm pretty sure the Team Mobile they still using, because they were using that both in Italy and in Brazil when I worked with them. I'm pretty sure they continued with Hadoop until today, if the project is still alive.
Yeah, the main Hadoop was based on the idea of big data, right? What was big 20 years ago or 15 years ago is not big anymore nowadays. And then the Hadoop as a file system becomes expensive and like tricky to use it. You can give up Hadoop and use object store in any cloud solution. You have object store, and it's faster and cheaper. And then because you don't need to spread the load in several machines, so Hadoop doesn't make any sense to use anymore. And then you don't care about infrastructure and maintain and patching and security. And then the other thing is the MapReduce idea that when Hadoop came, nowadays it's not fast. And again, people are moving from, so you can think in the history about batching, micro batching, and streaming. People are, nowadays everything should be real time, right? So micro batching and stream is the solution, so forget about it. And people are, today there's lots of pushing of doing everything in memory, fast, real time. So then
there's a lot of hardware has also evolved since you mentioned hardware. So
then Hadoop is kind of dying and people are not using anymore. Again, who has still using, but so you can do things in cloud or faster way, in a simple way, let's say.
Even more now with AI, right? So things getting mad. I don't know how much it will change for the frameworks that are currently existing, but they will be all being AI powered somehow at a certain point of the process.
Yeah, I'm lucky-ish, if you like, because I got the transition, right? So I kind of was there when they said so everything starts with the concept of external table. I don't know how old the external table concept is. This should be late 70s or early 80s. I guess was Oracle released the idea. So external table, the idea is, as the name already say, the data is outside of the database, right? So then you can create a table and you point for a path. And this path could be anything. The idea was Hadoop, but nowadays could be object store, could be a local folder in your machine, could be a remote folder nowadays, could be anything, right? And then when they had the problem of big amount of data, they said, let's do an external table for a file that I don't care where the file is going to be, right? And then because I have a table, now I can do SQL. So I can do SQL in that file. that I don't know where it is, right? You can even split the file in 10 machines, but I still can do SQL. So then now I can select and then some kind of explore the data in an easy way without understanding all the complexity about file system, distribution, network, and anything. And then when they saw that, I said, man, this is amazing. Now I can do anything, right? And since, of course, this was the idea, right? And from there, this was 20 years, 15 years ago. And then from there, from today, everything completely changed. Then we have partition, sharding, thousands of other concepts. The thing evolves a lot.
But that's amazing to see this evolution, right?
Yeah, so yeah, everything, like, they start with the external table, right? And then they said, okay, the problem of the external table, or one of the challenges, right? Think as an external table as a folder. So I have a folder, and then I can have files inside the folder, right? Then the challenges start like, which files I'm going to use? Do I create a binary file? Do I create a TXT file, or a JSON, or Avro, or Arc, or Parquet? Different files has some trade-offs, right? Faster to open, slower to open, or fast to read, or fast to write. How two persons are going to read and write together. Those are the challenges, right? And then there is loads of trade-offs, right? I can have a file in a folder. What's the trade-off of having two files? I can have a file with 100 lines, or I can have hundreds of files with one line each. What are the trade-offs, right? The OS, right, the open source, opens the file, then reads one line against open one file and read 100 lines against open 100 files and read one line each, right? What are the trade-offs? So then the guy said, oh, let's create the idea of partition. Partition is kind of a subfolder. So you have a subfolder inside the folder. And then you can partition by dates. So the idea of partition is you divide the data in the way that you want, right? So for example, imagine I have a sensor information, a temperature sensor. And then if I want to collect this data every 5 seconds, I'm going to have thousands of registers per day.
Yeah.
In 2 days, I'm going to have 2,000. And then a week, I have 7,000, right? So if I try to search per day, I'm going to scan the entire table or the entire file system just to get 1 day. So if I go with the idea of partition, I can create a subfolder per day. So then when I want a specific day, I just look that folder, right? And the same way, I can create more than one partition, right? Per day, per month, per year, per week, whatever. Or imagine I'm collecting sensor for, trucks. And I can create a partition, only the trucks where the data start with 0, only the trucks that are in US, only the trucks that are the Ford, whatever, right? You can create a lot. Then you can have the subfolder, then you only go in the subfolder and you read the data faster. Then again, they came with the concept of sharding. So, because it's a path and I don't care where is the path, I can split that folder in 2 machines or 10 machines or hundreds of machines, right? If the path is not a problem and I don't care, right? It's a network, could be different. So the file was a folder in one place, a second folder in another place, right? And could be worldwide. Then this became much faster and evolves a lot. I think they came with the idea of the MPP, right? The masses parallel processing. That is when Hive starts. I don't know exactly when Hive started, but I think it's 2005-ish, 2008 maybe. No, Hadoop is 2006, so Hive should be 7 or 8 or something like that. And then the idea of Hive was exactly that, right? External table for a path that you don't care with partition and sharding. So that was kind of a mind change. Early 2010 people was crazy about it. That's the way, that's the future. We can handle all amount of data of the world. We can do all the analysis, everything. And then was MapReduce and MPP everywhere. And then someone came with the idea of Spark. I think Spark is more or less the same idea. I can do the idea of the MPP on memory. So then I don't need things like Hive. Of course, on the beginning, people was doing both things together. So then Apache Spark appears, and people start to avoiding the MapReduce and preferring the Spark. There's loads of trade-offs in Spark. You need a cluster, you need to install things. And then involves a little bit, and people create what they call the Lambda architecture. The Lambda architecture was the idea you have batchings and micro batchings, and you can analyze things in everything together, or you can divide in small things and do micro batchings is a faster way. Everything was on top of a file system, and then that's how it grows, right? And then more file formats appears. Let's do Avro, ORC, folder files, structure files, right? Binary files, JSON, XML, right? Loads of different files, and then Hive, Spark, and things. People, of course, becomes a nightmare. People start to work with orchestration tools. Like back on days, Apache Uzi was a Java one. Nowadays, Airflow is most famous, is Python. And then how you orchestrate the things, you have loads of jobs, a sequence of jobs, right? You have what they call ETL, extraction, transformation, load. So you was able to run several jobs in a sequence. And then concepts of data lake and data warehouse was in place. Data lake is a place that you just drop lots of files. So imagine a file system, you just start writing files there, you don't care format, anything. And then data warehouse, that you create tables on the top of those files with structures and things like that. And then after a while, people, clouds grow up, people start, instead of Hadoop, let's use instead a path, right? Let's move for an object store. Then loads of the clouds start to provide PaaS and SaaS solutions. So I can have Hive, I can have Spark, I can have anything on the clouds as a PaaS as you go, a platform as a service. Next, it's up and running. I don't need to touch anything. I don't care about how I'm going to install, configure, everything's there, right? And it's cheaper and faster. And Object Store was almost free. And then people migrate to clouds. And then batching, micro batching. The guy came with the idea that if I have a micro batching and I still divide that micro batch, if I divide, I'm going to end up in a really small batching that is going to be super fast, that I can say that's real time or almost real time, right? 10 seconds delay, my micro batching is quite real time, right? And then people came with the idea of streaming, right? So I can do the streaming. That is loads of micro batching, but it's too fast that you have real-time data or almost real-time data. Then when streaming came in, loads of tools arrived. Kafka is one of the famous ones nowadays. And then the Lambda architecture drops. And people say, now I can do the Kappa architecture. The Kappa architecture idea is similar with the Lambda one, but instead of doing micro batchings or doing batchings, you do streaming. And then in the beginning, people start using both in the same way, and people say, you know what? I don't need to do the batching anymore because I can do everything on streaming. Of course, there's lots of limitations, right? But I can do everything there. So instead of keeping my Lambda architecture and my Kappa architecture and doing two things, I can get rid of the batching, micro batching, and do everything in streaming. Then loads of tools for streaming analytics appears, streaming database, and loads of things. And then they came with the term of lake house. That is the lake, the data lake and the data house together, the lake house. And then now we have table file formats. We can think about table formats, and they came with the open table formats. That is nowadays we have Apache Iceberg, Delta, Huji, and others. Then the table formats, the file formats, how you do it becomes a mess, right? Loads of things. And then nowadays they are talking about Stream Lake House or Stream House, right? There is two terms, Stream House or Stream Lake House. That is this data lake house over a streaming, right? And then you can do everything together, real time, in memory, no disk. There's I think in the last 2 or 3 years, there is loads of kind of people pushing, right? Loads of efforts to tools that you don't use GISC anymore, right? They
That
sell
one
like
you
no GISC
mentioned, Igor,
movements.
the streaming with data lake is kind of, you have all that mess there in any format and you just grab that very fast with the streamings.
Yeah, so the idea is you use the concept of data lake, so you have the data there. You don't care about format, anything.
Just throw it. Okay.
Then you have the same idea of external table that you can map for there. But
You
the
will
external
map
table,
what
you
was
map a
there.
folder, you map a file system, right? So they came with the concept that they call material view. That is a kind of view, the same view concept of the database, but in memory. There is no path anymore. Everything is memory, right? So you can create a table or materialized view from a file that you don't know the format and keep that thing in memory. Now you can run queries in a table that's in memory. That's the idea.
You
All
just
real time.
search on it because it's always on the memory, right? So
Yeah,
it's
but
always
then you need a so when is a data that is time sensitive, right? So you have concepts of, they call windows. So you look for the data in a specific amount of time, right? So what's happened in the last 5 seconds, what's happened in the last half an hour, because the data is time sensitive, right? So it's kind of the partition, but it's a windows, right? Similarly, it's kind of a
yeah. Don't mention Windows because
naive
it will
comparison.
stop working. If you mention it's Windows, it will stop working probably.
Yeah, but it's
You have a low
not
speed.
Windows as a OS, right? Windows as a
Without the
period of
S.
time. Yeah.
Yeah. And Igor, for talking about, amazing to know all
This was the last
history,
10 years, 20 years history. Yeah.
Yeah.
Yeah,
Yeah,
and,
it was
you
amazing
share all the
history.
past, and many things change. And I want to talk about the future. So, what's going to happen? What do you think it's going to happen? And not only that, but also, let's say for beginners. So, let's say that I want to start working as a data engineering.
Yeah.
What should I learn from now to the future, in your opinion, of course?
Right.
And also, if Java is relevant or not, because you talk about Python, and we know that
Yeah.
Python, it's really related with data things. But how about Java? And before I pass the word, let's say hi to Inocencio. Hello. I hope you are understand everything. If anyone has any question, please put on the chat. I think this is a great moment to ask things because you have here a very
So let's talk about the first question, right? About the future. I think the future, what we are seeing, what is happening, right? First is there is a concept of on Kafka. So Kafka, think it as a streaming as an array or a pipe or at least whatever you want to call, right? Something that you append elements, those elements in say memory. After a while, you write on disk, right? But you work on memory. So Kafka is adding, I think it starts on 3.9 or 3.8 version. The 4.0 is production ready. The data goes there on Kafka, and over a period of time, that thing is they write that thing on object store, right? So out of the box or in a kind of in a transparent way, the data that is there is going to be persisted. So you have a streaming real time, but your data is persistent, so you can come back with the idea of batching for free. You can have both together, right? And then what they are doing is they releasing things that you can figure out what is the file format or the table formats that you're going to write. So Confluent has the iceberg formats, right? So you, out of the box, your data on Kafka is going to be there. So then you have all the tools for doing everything in a simple and a faster way, right? So you're going to have a data lake and data warehouse. You're going to be able to do streaming and batching or micro batching, everything in once without loads of configuration, loads of tools, loads of things, right? So that's kind of the future. Once you have this in place, is what they call the lake stream or the lake streaming lake house. You have everything there. That's one thing. Then Kafka grows up to things like how he can spend less money and do more things in memory, how he can avoid disk, right? Because one of the bottlenecks of the Kafka is persisting on disks. Then, anyway, nowadays there is loads of Kafka competitors and things like that. That's one of the filters, right? When you're thinking about a data engineer is a broad term, right? It's kind of a soft engineer. There's loads of things, right? In the past, people usually to talk about data science, data architect, data engineer. The terms they overlap. I think it's local. Each company means one thing. There is data engineer that does not code, and then there is data engineer do code, right? But I see data engineer as three things nowadays. One is the JNI. JNI you can translate in LLM, and then RAG, and then machine learning. You keep going, and you end up in statistics and math. Then the second part is the data pipeline. That is what I told the history of the last 15 years, right? So streaming, batching, those kind of things. Data lakehouse, lake, whatever. And then the last one is the data mesh. Data mesh, data fabric, data mesh. It's kind of more about the process and things like that. And then you translate it to like DDD, domain, how you divide data and domain, the culture of the company, design patterns, Kubernetes, those kind of things, right? So a data engineer is going to overlap on one of those three areas. How to start is you need learning basic of database, how a database works, how NoSQL works, how object store works. Then external table, partition, and sharding. Those kind of things are the basic, right? Then you grow there from frameworks and tools and things like that. The machine learning part in tools like Spark, and there's loads of things. Majority of them are Java based, and people do in Java, right? There is a misconcept that machine learning is only on Python, but I guess there is lots of people doing things on Python, but anyway, everything is Java, so you can use it. There is the data frames and things that's more common or popular in Java or in Python, but again, you can do in Java anyway. As I said, everyone that is on Hadoop, it's based on Java. Everyone that is, if you think about Spark, right? There is Python, there is Scala. I usually to joke, right? That's not a joke. It's my theory. Java release. So MapReduce started 2006, 8, right? That's the idea, right? And then back then was Java 7. Java 7 doesn't have the stream API. And then because of not able to do in stream, people saw in Scala, I can write my MapReduce or my MPP, right? Massive Parallel Process in Scala, really more faster, better, easy to read than Java. And Scala is Java based or JVM based, so let's migrate to Scala. And then if you look Forbes, E3E or Gartner or anything, you're going to see that Scala grows from 2011 up to 2016. Apache Spark was created in Scala. Kafka was created in Scala, right? There's loads of tools back on that stage that was in Scala. And then 2014, Java released the Java 8 with streams, right? And then it took a while for people to migrate to Java 8, but if you look 2016 or 17, 2 or 3 years late, Scala starts following, right? Of course, Scala did some different things. They released a version that is not back compatible. I'm kind of forcing that was the stream that broke Scala, but nowadays Scala is falling, right? And then when we arrive 2020 or 18-ish, same thing happens with Kotlin. People from back on 2018 or 19, people start to play with what they call data-intensive applications. And then people will say, I don't have anything. The idea was coroutines, right? I cannot do coroutines on Java. So I can do in Scala or in Kotlin. I can do on Scala as well, right? But Scala was problematic in the past, so let's do on Kotlin. Again, it's JVM based. So people migrate from Java to Kotlin because they have coroutine. And what's happened? Java decided to add the virtual threads. That is a coroutine implementation, right? Then Java 21 released with virtual threads. Now is ready to use. And what happened? You see Kotlin grow. Now Kotlin is kind of it's not falling because you have the Android market, right? But it's kind of the data engineer people are kind of okay. I don't need it, Kotlin. I can go in Java. Virtual thread is still loads of things need improves a lot, right? But that's my theory, right, of the wave of things. So, and what's happened? Kafka was
thanks
writing
to
in
this-
Scala. They started
thanks to
migrating
these
to Java.
languages, right? Just adding to what you mentioned, Igor. Thanks to Scala and Kotlin, we can see the evolution of Java.
Could be.
Because Java have been a very long time stopped without any evolution, and then when Oracle took it, we started to see a release after another. So that's the competition on the market. And yeah, I didn't saw the Kotlin dropping as well, but it's great to see this evolution with Java and becoming a modern language. Because for a very long time, a lot of people, especially Python people, were saying, "No, Java is dead. Java is not gonna be used," and all of that kind of stuff. But it's kind to see how the old dinosaur is always reborning as a new baby and a phoenix, and however you want to say, but it's getting powerful, Java.
Yeah, it's different when you say. I think there is lots of mis things, right? It's misleading here, right? I think, especially in Brazil, right, or especially people who use the internet banks, early 20s, people misleading or a misconception about Java was the JRE that you install on Windows machine to have applets, security applets in. So people believe that that thing is Java and Java is low. And then when people talking about Java is too verbose or Java is slow, those probably are junior people that doesn't understand what is programming. Like you need to think about the paradigm, right? So Java is object orientation dated. It's a type safe language. So you need type objects. You need to understand what things you need to create objects. And if you compare with Python, that you don't need to create objects, you don't care about types. Of course, after Python 3, there is options to add types. It's not obligatory, and people can create kind of a object orientation and procedural in the same time, right, on Python, and then you mismatch everything.
You don't follow a pattern.
And then when you said for the people, no, you need the obligatory write type. You need obligatory write if there is no return, right? Void. And people, it's too verbose. I usually to joke that is the lazy generation, right? If the person is lazy enough to, it's like people who works with JavaScript, right? I don't like because I need to put a type. Man, you don't know. You need to learn the principles, right? What's happening around? So
that's good. The good thing about Java, because when you read the code and you get all the logic, it's verbose because it's explaining you everything that it is doing. There's no hidden magic. Of course, you do have frameworks that helps you with kind of magic, like Quarkus, like Spring. But if you understand the magic behind it, there's no magic.
I always joke that you need to understand what's happening, right? I think it's kind of the curious, how curious you are. Like if you ask for maybe half of the people that work with Spring or Spring Boot, if you ask like what is the web server that it's happened, what people are not able to say Spring Boot brings Tomcats. Tomcats bring 200 threads. These 200 threads spend half X memory. So I spoke with people that is, I don't know, 10 years in Spring, 15 years in Spring, and what? How you know that is only 200 threads? 5 seconds on Google, I discovered, right? So it's how curious you are. And then nowadays you have Micronauts, Quarkus. What are the trade-off? Why, if I create application in Spring, I can choose my web server? Why, when I create an application on Quarkus, I'm not able to choose my web server? There is a nice explanation why, right? So if you miss those information, if you don't go those informations, doesn't mean that you're not going to be able to use the framework, right? You're going to be able, but when you know things, right, it opens the door, like, and it's the same with paradigms, right? I usually to say that a good programmer should know one object orientation program, should know one functional program, and should know one procedural program, right? Logical and the other two doesn't. It's not that you don't need to know. It's nice if you know, but they are not too much used in the market, right? So you can choose any language, and I always usually to say that get the most one, right? So you can learn object orientation with C++, but it's easy to mix with C, and then you're going to do procedural and orientation object at the same time. You're going to be confused. So if you get Java that is object orientation, it's easier, right? The same with functional. You can learn functional in Kotlin-ish, or if you go in Scala, you're going to learn better things, right? And then when you start to approach different things, your brain like open, and it's what happens with me, right? I start with my background in Java. I get the Scala wave, right? So I start functional things. Everything is functional. Streams
nice,
everywhere. And then when I back to Java, right, my mind was, now I understand functional strings. I understand how string. I moved to Kotlin and I start to work with coroutines. Then when Java came with the idea of virtual threads, I said, virtual threads is coroutines. I know already what coroutines, right? So you brings I think you speed up, but be careful, right? This is something that happens over time, because when I say to people, you should learn at least one language each paradigm, what's happened is they try to learn everything in once, right? Yeah. You're not going to learn 3 languages, 3 different paradigms in 6 months. No.
You get mad and you will not learn anything. It's like trying, let's not put on programming languages. If you try to learn Japanese and German at the same time, you will mix them.
Yeah. And I always say the same thing. Programming is not one thing that you learn in 6 months, right? 6 months. One of the things, there is a really funny thing, right? There is a famous series of book that is learning the language in 21 days or learning the language in 7 weeks. And there is for Java, Python, C Sharp, right there. And everybody that see that book start laughing and said, this book's not true. This is fake-ish. But they misunderstood the book, because the book is not going to teach you the paradigm. The book is going to teach you the language, and the language is a sequence of instruction, right? So Java has, I don't know, around 200 reserved words or whatever, right? So that's what the book is going to teach you. The book's not going to teach you how to program. The book's not going to teach you object orientation. The book is going to teach you Java syntax, right? If you get the Java on it. So then, of course, you can learn maybe in 21 days or weeks, whatever, right? So those are the difference, right? Programming skills is something that you overcome 6-8 months. So when you see bootcamp learning language X in 3 months, I'm sorry, but no.
Get stressed in 3 months and get mad out of it.
Don't get me wrong, right? I'm quite sure you can do 3 months course of something and you're going to be able to find a job. You're going to be able to do, right? But
I believe
not
that
the same.
And also learn. You probably learned something, but to master and really learn, you need to fail. And to fail, you need time.
And with the data engineer part, it's the same, right? I said loads of tools, right? Spark, Kafka, Pinot, Hive. Again, you're not going to learn then over 3 months, and don't try to learn all together. It's fixing one thing, right? You want. Yeah. You can always keep reading, and right? For example, here in Ireland, I kind of start a IT group for Brazilians. On Facebook, we have around 15K members. We do a meeting once a month. There's lots of people. So I kind of in an infinite loop, right, for the last 10 years, seeing lots of things regarding how to position in the market, how to create a CV, how to do an interview, right? So I'm kind of good in that sense in mentoring people and this kind of thing. And one of the things is regarding learning, right? How you learn, how you improve things, and how you keep, right? So I like the idea that you can keep reading and you know the things, right? In IT area is huge, right? So for example, blockchain. Blockchain is not my area, right? I never worked with blockchain, but I understood more or less some protocols, how they works, right? Hyperledger Fabric, more or less what is, how it works. Never worked. It's not my area. I don't have interest, but somehow I read about, right? I know it. Is GenAI is another, right? Despite I'm kind of dating. GenAI is not too much my area, but I know what's GenAI, what is LLM, right? Well, how you do a RAG. Nowadays, there's thousands of different ways. We are in the that's another filter. The wave is from SaaS or software as a service for Gen and HAGs. So instead of doing HAG, you're going to have a software as a service that is going to get to discover for you what's the best way to do the HAG for you, right? There is more than 20 ways to doing HAGs nowadays. Graphic HAG, acrylic HAG, discovery HAG. That use the document, use the labels, use the links, use the every day someone came with another way to do a better HAG. And there is a term, I forget the term, that is the idea of this. No, is argumented or I forget the term. So, but the idea is they try. So that's what I say. They filter for SaaS HAGs, right? So you said I have a data set that talks about I don't know, medical clinical trial, whatever, right? So if I get any LLM on the markets and ask anything about medical stuff, it's not going to know the answer, right? So then what you need to do is the HAG, argument that data with medical trial or clinical data, right?
Mhm.
Then for doing that, you do the HAG. But there is lots of different ways to do the HAG, right? Then one of the ideas is that you have a SaaS solution, right? Software as a service that you gave the model. So for example, I'm using the model X from whatever, and then you said I run the RAG for medical, clinical, and those are my PDFs or my data sets. And then the SaaS solution is going to try different techniques and is going to answer you what's the best, right? In a faster and in a cheaper way and private, right? Because the problem of LLMs and RAGs and models, no one wants to share the model online or no one wants to share, right? Instead, of course, you can put in a cloud and it's private for you or for your domain.
Mm-hmm.
But then if the SaaS solutions provide you the best way to do it, then you know what to do cheaper and faster, right? That's one of the things that I believe that we are going for. And
interesting, yeah.
And then there is the ops part, right? The infrastructure, right? We usually to have DevOps, and then becomes SRE, and then now we have the DRC, right? The data reliable engineer, right? Or the data SRE, if you like, or dev or data ops. Then they have the ML ops, machine learning ops, and nowadays we have the LLM ops. So yeah, those are the.
It's all ops. Every time I have new op.
So we have the knowledge graph,
right?
The graph, the key knowledge graph, document, version, labels.
Wow.
I just said 5, right? But if you search on Google ways to do HAG, I think there is more than 20. Which one is the best? And the other thing is funny, right? There is no best approach. Everything depends of the data, depends of your model, depends of so. There is no
the use case as well.
That's another area for a data engineer. Maybe this is more kind of a data science or whatever. Someone
and
who
Igor,
likes more maths.
I have a question for you about data engineering. I believe you mentioned Gen AI. It would be, is it an area from combining data engineering with AI? And how it's seen to the other areas of AI? It's kind of looking more as a partner to help digging into
Yeah.
all of that data, or it will kind of kill the area? How it's being seen?
Gen AI is generative AI, right? Generative. And this became kind of a commodity, right? So nowadays,
Yeah.
you can get the LLM model. You can create your deploy local, right? Or public for you on premise without knowing anything, right? So I don't know anything about data engineer. I don't know anything about machine learning or any model, or even I don't know what LLM means, right? But I can do it. LangChain, Cloudy, there's loads of options in the market, right? So you can create a Spring, a Quarkus application that has a model, embeds local on-premise without knowing anything, right?
Okay.
I can deploy that and I be able to ask questions, right? I have a chat and I can ask questions and I get answers. You, on the top of that, you are able to do a RAG without understanding what is RAG or the types of RAGs, right? And if you Google, you're going to see loads of Spring Lang4j, Spring Cloud, Spring Olama, Spring, all the options, right? And you can do it. And this is good, right? I see a nice example. I think it was Micronaut, if I'm not mistaken. So the guy has informations about products, and then he was able to talk with I think it was Lang4j, and he was able to talk and say, for this product, generate a description and a picture, and then the description, the picture was in the website, and he was creating kind of a cards website that you can buy items, right? Without knowing what is LLM, without knowing what's model, right? So that's what I'm saying. Gen AI becomes a commodity, right?
Yeah.
Now the data engineer part in that process, or maybe the data architect or scientist, is more about the model itself, right? How I improve the model, what's the algorithms behind, the math behind, right? The approach. And then the same idea on the RAG. Should I do a normal RAG? Should I do a graph RAG? Should I do a dimensional documents? Should I look the labels? Should I ignore the labels, right? Those are more data people. But again, there is nothing against you play both sides in the same way, right? I suppose to say. And even the other thing, Apache Spark. So one thing that's funny, right? Data intensive application, famous book, Design Data Intensive Application. Mark Kaplan is from 2017. End of 2017 or early 2018 was of the best or the most book that every data engineer should read. Nowadays, 2025, that book is all software developers should read, right? So the thing shifted. Everything that you search on the internet regarding software developer interview is going to say that you need to read that book for prepare yourself for a software engineer interview, right? So the thing that was extreme niche for data engineer 5-7 years ago now is developing, right? And then the things move the opposite as way, right? Apache Spark, Apache Kafka was really a data thing. Nowadays, developers are more Kafka stuff, right? So if you look for a role that is going to play with Kafka, they are looking for. Of course, there is the data ops guys, infrastructure, but they are looking for developers. If you are a data engineer and you say I want Kafka, they are going to say, yeah, no, wait, we want a developer, right? We want a developer. So that is kind of a prejudice, if you like, right? And then the Spark is the opposite. The Spark started as a coding base. People need to know Scala. People need to know things, and then over the years became a data engineer stuff, and then a developer not necessarily plays with Scala because Scala is more for the data guys, right? Or Spark, not Scala, Spark. So things go both ways, right? That's
I
so.
see. Yeah,
And then
but Igor, the question would go more in the way that is the AI or LLM seen as kind of a menace to the data guys, to Spark, and even for Kafka? Let's suppose instead of having a data lake using with streams, I would just get all of this data and have my own LLM trained, because I could kind of access it more quickly and smart. How is that be seen into the data engineering
I think we are
guys?
far from that. It's possible, but we are far. There is lots of examples where you mapping your table schemas in LLM, so then you can do natural query, right? I write it in English, and this is
Yes.
converted in a query. It's possible, right? But when this is going to become a thing, it's like saying that the AI is going to kill the developers. It's the same idea.
Yeah.
Maybe in a future we will, but we are far from there. It's the funny stuff, right? People say, nowadays 40% of the Google codes is AI generated, right? But if you go in the Google career, Google has thousands of developer roles, right? So why? How you? It's like the Jane and I, right? The idea, right? The Chat GPT. Everything is code based, but they are they are desperately looking for developers, right? So I think the AI like improves your work or accelerates your work, right? Makes you do things faster. Learning how to use a prompt of AI is a skills, right? It's like 15 years ago learning how to use Google, right? So if you know how to use Google, you find the answers faster. You have a problem in your codes, right? You Stack Overflow, you Google, you find faster. It's the same nowadays. So if you know how to use Copilot, ChatGPT, or any other, right? So improves you faster. And nowadays it's really common. Convert this code more idiomatic for the language X, right? I have a function put this function more idiomatic in Java, and then he gave the solution and explanations what's happening. If you don't know, it's okay. Why you change this method to that one? And he gave the explanation. So in a faster way, you improve your code, right? And the other point is tests. I want to cover my test, right, or increase the cover. I need, I don't know, I'm working for a bank, my code should be, I don't know, 80% covered by test. So I write one test and ask the Copilot or Jane and I, can you create the rest of the test for me? And he do it, and it's perfect, right? So this doesn't mean that I'm going to lose my job, right? So just speed up my process.
It's a tool to help you, especially with repetitive tasks, right?
Exactly, yeah. I think it's the same vision everywhere, right? Now, small things and simple things. Again, if I'm a junior and I just did that course and learn Python in 3 weeks, maybe I'm going to lose for the AI, but it's a trade-off, right?
And the junior needs to continue to evolve, and he can even use AI to help him to learn. Many people want the AI to have the job done for them instead of using it to learn. And most of the times, you're just asking it to do it for you. It does not understand how contexts, so it will give you wrong code.
Yeah, so learning how to use the prompt is a skill, right?
Yes.
So if you're learning how to use the AI, you have advantage nowadays, right? I think we are in that area, right?
Absolutely.
If you learn how to use the context, and you have advantage.
Yeah, exactly. I used to say that, as you mentioned it, it's like Stack Overflow when we have to find some answer and get back. And if you don't understand, just copy and paste. It's the same if you don't understand what AI
Yeah.
says and copy and paste and
Exactly.
and don't know anything, and you end up with bug, but with much more scaled way, right?
Yeah. Yeah. There is a famous T-shirt. I think anyway. It's regarding a hacker, right? I'm not a hacker. I'm just know how to use Google better than you, right? It's the same idea. I'm not
So
a
yeah,
developer. I just know how to use prompt AI faster than you or better than you, right? It's the
and
same
that's
thing.
yeah, perfect. Yeah, perfect. But here, and I think one very important thing is that, at least for me, data is the source for any AI to work well. So if you don't have good data sources, if you don't organize it and manage it well and keep it clean,
Yeah.
so and concise, you won't. There's no AI that will help you, that you can train, that will be helpful for you. You're gonna have, I think, I don't know if in other countries, but here in Brazil we have that shit in, shit out. I think it's common to any other places, right?
Yeah.
So
Yeah.
we
Yes.
still have people that understand data engineering and keep all this data life cycle
Yeah.
working well, right.
There is I think this was. I think it started 2015 ish. People were. The idea was when they came with streaming, right? First, people when they start talking about streaming, there's lots of people that misunderstand data stream and streaming as a video. Like I open a YouTube or I open Netflix, I'm streaming, right? So there is those difference. But then I think people will start with event source. Then was complex event source, the SEX, the CEX, and then event streaming, complex event streaming. And what are the difference, right? It's like for I don't know. I usually to joke, right? Is different authors create different names for the same thing, but with a slight different view, right, of interpretation of the things, and then thousands of different acronyms, and but everything on the same is the same thing, right? It's almost right. It was funny, and then how you create, for example, right, as a developer, I'm going to do a micro batch or micro services that is going to do event sourcing, and then what is events, how I deal with events, right? And then no, I'm going to do a Microsoft that is streaming based. No, I'm going to do a Microsoft that is uh, event process based, or event complex event process, or complex. When someone puts the complex in the naming, right, you start laughing already. So what the heck is that? It's not
Complex
complex at
code
all.
manager. Two
And
two words that you will you start to worry about, right?
yeah, it's already
Yeah.
complex. Why you want to say complex? It's
Don't add
funny.
complexity. Keep it simple,
Yeah,
please.
but
So
I guess, like as I said, right? I have a group and I see lots of people in the area and lots of things. I said here maybe today lots of different tools, right? If you're not on data area, you probably never heard about those tools.
Yeah.
That means that you need to go there and study and knows that no, it's exactly the opposite, right? If you want to focus on data engineer, then you focus there, you're learning, right? That's the example that I said about blockchain. I don't work with blockchain. Blockchain is not my main area, but sometimes I read it about. I know I have a notion, right? This because I have 20 years experience in the area, not because I have 2 months experience, right? Over time, you so create the habit of reading a little bit every day. I think there is FUJI, Friends of Open Education. There's a nice site there. They have a blog, and then they have this idea, right? 1 or 2 blogs posts per day. So then every day you can spend 5-10 minutes reading about different areas, right? You read about blockchain, you read about data, you read about GenAI, you read about design patterns, Kubernetes, whatever, right? Different language, Python, Scala, Kotlin, or hardware, right? So you knowledge grow, you understand more things. That doesn't necessarily mean that you need deep dive and understand everything, right? There is two different scenarios. Now, do you need read and know everything? No, it's completely okay if I say I don't know anything about blockchain. I don't care, I don't mind, and not work with. It's completely okay to say I don't know anything about data, right? I don't care about Kafka, I don't care about things. Then it's up to you, right? If you want to know or not. Now, deep dive is only if you work on that area, right? And again, don't confuse a deep dive with knowing the basics. So, for example, if I'm going to work with a Spring application, it's really good for me to understand which web server Spring puts there and why, and how much memory or how many threads, right? Now, if I'm not going to work with Spring, should I know? Depends, right? But that's the idea, right? So if I'm going to work with Kafka, it's benefit for me to understand what's happening behind the scenes. How is the everything, like the bits and bytes that happens around. I'm not going to work with Kafka. I don't care about Kafka. I just need to know the basics, right? Kafka is a stream. That's what I said, right? There is loads of misconception about streaming and queue, especially when it's a Java person. People say, Java is Kafka JMS, Java Message System. Then I was like, no, right? So this is a really most common misconception. But again, it's okay, right? If you're not familiar with that. And so this means that if you're watching this, you don't need to go there and learning open table formats, Apache UD, Iceberg. Don't do it unless. But it's nice to read about and understand. What is GenAI? What is a RAG? Or what is LLM? Or what is Kafka? What's the difference between streaming and batching, or streaming and queue? Right? It's nice
Just
to know.
know the concepts, right?
Yeah.
And
What
if
is a
you're
data
interested
lake?
in that area, you
Yeah.
dive deep on that.
Yeah, so you don't know. You don't need to be a master in Spark and Hive and Pineouts and
Everything you read.
You
DuckDB.
remember.
Yeah.
You remember a lot of things from my career back then when I worked with off that I didn't remember at all. The Hive.
And it's the same with the languages and paradigms, right? You, as a good developer, you should learn one language for each different paradigms. Focus on the three famous: object orientation, procedural, and functional. But give it time, right? It's not going to happen in 6 months. Maybe 6 months in one, 6 months in the others, and then over time, right? Don't try to go crazy, otherwise.
It's not gonna be
Yes, and
21 days, right?
Yeah.
And there is a famous books, the Pragmatic Programmer, that also talks about that you should try to learn a new programming language with a different paradigm every year, or try to do that kind
I
of
think
thing.
your brain like opens. It's like
Yes.
when you're doing the graduation, like if you go into college, right? I'm going to do computer science. On the first year, you learn calculus, right? Calculus 1, calculus 2, calculus 3. Majority of the things that you learn there, you're not going to use it, or maybe you don't use it, right? But you learn anyway, and that thing opens your brain, right? So you learn loads of things. That in that sense, I think is the idea. And then there is loads of development topics that mismatch with data engineer. For example, data orientation program or design patterns, right? We have the Saga design patterns or the CQRS, right? Those are more developer stuff, but it's related with the data stuff, right? And microservices in general, right? Microservices is more a developer topic. How I create microservice, how I deal with that, right? So if I have two microservice applications, how I exchange information from A to B. REST interface, GraphQL, or gRPC, right? What's the trade-offs, the pros and cons? Should I have a queue, message queue in the middle? Should I have a stream in the middle, right? What's the trade-offs? And then if I have 3 applications, I think the most common microservice applications from messaging queue and streaming is the application A is the product, the application B is the financial, how you pay, and the application C is the stock, right? Do I have a stock? Yes or no? So imagine I create a cart application. I want to buy, I don't know, I want to buy a TV. So I browse there, I choose and click buy the TV. Or flight reservation. I want to create a flight reservation. Right? The first application shows the products you choose, you select the order, right? Then communicates with the second application that checks, do I have that product in stock? Yes or no, right? So if I have it, I kind of reserved one because that person wants to buy one. Then once the product goes in your cart, you want to finalize the thing, you need pay. Then you communicate with the third microservice, that is the payment system. Should the payment validator. So what's happened if on the payment fail, or if the person remove the product from the cart, right? So
Or
that's
have a race condition.
That's the Saga pattern that you explain how you
Roll back
asynchronous way.
things.
In asynchronous way, you keep everything in place, right? You undo some things and then you send messages. You create a stream to say I want an order, and then after a while you send another one to say cancel that order. What's happened, right? How you handle it. That's one thing. And then the CQRS is the idea of you have application with 2 databases. Right? This is a naive explanation, right? But you have 2 databases, a simple explanation. And then you write in one database and you can read from another one. Ish, right? That's the idea. Anyway, there's loads of... There is a famous book. There's 2 nice famous books. Microservice Architecture, that explain loads of design patterns of microservice. Saga is there. CQRS is there. Right? And then there is the microservice patterns. Those 2 books, they explain loads of things, right? I think you have the famous Microservice IO.
Yes, I think it's Microsoft.
Yeah, Microservice IO.
Maybe this is the famous one about
Microservice. It's the Microservice Patterns book, right? The same guy.
Yeah, yes.
Really nice. You can find a lot of things.
Yes, and there is also another one. If anyone here wants, I think it's free. It's from Microsoft. If you search for cloud design patterns, you'll find a lot of design patterns, and there is also a book, and it's free. If I'm not wrong, it was. So yeah.
Yeah, the famous one is the design data intensive. That's a famous one, Market Clapper. Then there is Kubernetes patterns as well. That's a nice thing, right? You have design patterns, you have Microsoft micro architecture and patterns, right? Microservice patterns, and then you have the Kubernetes patterns, and you can have all 3 together. That's right. So how you combine CQRS with Saga or with Kubernetes patterns, right? You can have those mix match. It becomes more tricky, but yes. And then the other thing that is common is CDC, change data capture. So the idea of the CDC is every change on the database, you create a notification or you create an event that something happens on CDC. Again, CDC is, I don't know when someone created, but I supposed to say is early 80s, late 70s or something like that. But CDC became more popular maybe in the last 10 years or when you became with the real time. But Debezium was of the change curve because Debezium apply the CDC idea on streams. So then instead of sending an event or a message, you have a streams, right? Debezium is a really popular tool nowadays, and you have the change data capture on real time. And I think it's from 2010-ish. I'm not sure. That's a good... But yes, it's still kind of something that changes a lot. And then with that, right, it's really common. You have an application, you have a database, or you have microservice, you have different database. Then you have CDC on top that changes everything or get the change. One of popular user cases. I want to see what the user are doing, right? The actions of the user, or engagement of my users, right? Who is doing what, or for audition, security, for right, for doing the life cycle, or doing the things like that. It's really common scenario, and again, nowadays you can have in real time. And the last one that I said is data mesh. It's more about process. Data mesh and data fabric is more about process. And DDD, right? That's the funny stuff. DDD is from 2002. There is the famous book, the blue one from Eric Evans, right? Eric Evans, 2004, more than 20 years ago, 21 years ago. And nowadays, there's still people that doesn't understand how to use it. Loads of people use it without knowing, right? Because it's how you divide a domain is too generic, right? There is no right or wrong, so you can do whatever you want. And then data mesh is the idea of applying DDD in data. So again, I don't think people the next 20 years people are still going to talk about data mesh, how I divide my data in domains. There is no right or wrong, right? There is no silver bullet. So it's funny.
Yeah, I think we are getting to the end. I think we passed actually our time. Uh, I want to thank you, Igor, because I really enjoyed this talk. You talk a lot about the history and how things going. You have an amazing background. But before we end, I want to pass the word to my friends. I don't know if anyone here have any questions, so we can end up with maybe a last
Yeah,
round of
just
questions.
want to thank you, Shara here, Igor. Thanks for bringing all these subjects and your expertise and the history of data engineering and the present and your history as well. It was very interesting to listen and to learning, and especially for me because I had a past on data engineering and worked with almost 2 years on that. So it was kind of a flashback when you started mentioning MapReduce, Hadoop, Hive. Oh my god! Some remembers were good, some of them not so much, but they are part of the experiences of the past. So thank you a lot for being here with us.
I saw recently, right? I don't know. I found it on Google. I don't know the variety or how true is this, right? But I think it was from 2004, no, 2024, a year ago, regarding Meta has the biggest data set worldwide, right? And then they was saying that Meta itself, only Facebook itself, they move it and they shifted 4 petabytes of data per day. And they have it around 300 petabytes of data in Hive, and they still using Hive nowadays, right?
Oh,
But the entire data set, or the full thing of Meta was about exabytes, right? So if you're thinking about sequence, right? So you have mega, giga, tera, penta, hexa, and zeta, right? So looks like this was a year ago. Maybe it's increased or double nowadays. Right? So Meta was about 47 exabytes,
you
the
can
biggest
just
data set
imagine.
worldwide.
Just imagine how much data they collect from us.
Yeah.
You
I think the
input
second
some.
biggest was Google.
Wow, the second one.
Yeah,
Wow.
because Meta is combination of 3 or 4 social
Instagram,
network. Yeah, yeah.
Facebook, and I
Yeah.
don't know which other.
Anyway, it's loads of data. Right?
Yeah.
I'm on.
So we have here Max. Hello, Max. We are
Hi,
getting
Max.
close to the end, but if you have any question, please ask here. I think
Let
this
us
is
know.
the last opportunity to ask for Igor,
Yeah, just
at least today, at least now.
just remember everyone and your audience as well that tomorrow starts TDC. We will be there. Me, Luis, and Hugo. We will all be there in person. TDC Summit São Paulo. I will be on the mentoring hub with mentoring about international career and communication. If you're around, come on, subscribe to this mentorship. Also, Hugo is with mentorship on the 27th, on the second day, right? And Luis, you are the coordinator of all that stuff, right?
Yes,
So
come reach out to us in the mentoring hub. It will be amazing there. And Igor, thank you so much. I really appreciate your time here, and especially the historical context of data engineering that you share with us. How can people reach out to you?
So you can IGFA Souza. I think is the best way. Let me write down here. I guess can I?
yeah, we have shared that on the chat to all the audience.
Yeah, I can write.
Your website, right? lgfeasouza.com,
Yeah, you
right?
can
Igor?
find me everywhere. .com is my blog. /blog. You're going to find my blog, but I'm in Twitter, I'm in Blue Sky, I'm all social. I normally share Kafka content. Actually, it's been almost 2 years. I follow the idea, as I said, Full J, Friends of OpenJDK, right? Every day a new article, read 5 minutes a day. I follow this thing for the last 2 years. I'm sharing Kafka stuff. So if you check my social content, you're going to see that I'm sharing loads of Kafka things, and sometimes, not sometimes, majority of the times, it's not my blogs, right? Things from the others. So don't see me as a bot. See me as something that is sharing 5 minutes blogs every day, right? But again, I have lots of things on YouTube, and I'm not new on SoJava. I'm I was the host for all international calls on Quarks Club. So if you don't know what's Quarks Club, is kind of a Discord from Quarks group. And I've been kind of close. I work in a big cloud provider, let's say, and I was close with Micronauts development team, and I do Quarkus things. But majority of the time I work with Spring. So anyway,
You
all
master
areas,
all the frameworks.
all the areas. Yeah. I never worked with Quarkus. I never worked with my previous company was Micronaut, but I never worked with Quarkus. Spring the majority of the time. Anyway, it's funny.
Okay,
And you're going to
you.
find lots of hardware things. Hardware is with data, hardware is with Java. That's
And amazing things with hardware. You play around a lot with Raspberry Pi, right?
Yeah.
So you have many cool stuffs with Lego. Yeah, I
Yeah,
do remember.
that's one of the things, right? Things like can I run Kafka on the Raspberry Pi? Kafka, yeah, you can. I know that you know that you can, right? But those kind of things. Can I put Hadoop on Raspberry Pi or Spark? Those kind of things. Right?
Yeah. And now I pass the word to you, Chila. I don't know if you have any
Yes.
questions.
No other questions, but I would like to thank you, Igor, for sharing your knowledge with us. So I had a great opportunity to update my knowledge on all these tools, and it was very interesting to listen to all that history what you shared with us. So it was a pleasure, really.
No, again, thank you so much for the opportunity. Again, it's areas of my interest, right? I spoke a lot, so I think I gave a nice overview. I try to pass my ideas or my history view, right? What I believe happens in the market. Scala grows and fall, and Kotlin go and follow the waves, and my crazy theories. But again, I have lots of experience with mentoring and things like CVs and things because I have a big group here. Maybe in the future I can come back and talk about this, but it's another thing. I play with hardwares. I think I already came in here in SoJava with hardwares anyway. But anyway, feel free to find me on social network, bring questions. I will try to do my best to answer. And again, thanks so much for the time.
Yeah, again, thank you for being here. And also, you have an amazing background. So, of course, maybe we can schedule in the future another session because I know you have many things to talk about and we can discuss many subjects. So, thank you again for being here. Thank you, the audience. And just to add up, I think Max asked a question, but I think we have answer. So if you want to meet Luis, Igor, and also Hugo, you have an amazing opportunity in that. Join the TDC event. So they will be there talking about things that can help you to grow in your career. So many stuffs related with that.
That's
And
it.
Max also shared that he wrote a post on Fuji. So another reason why you should follow Fuji, because there are many things that people in the Java area write about. So you will find many different things from different authors. So yeah, it's
And it's
a,
not
a
only a blog,
really
right?
nice.
They have the Discord. No, they have the Slack. You can join the Slack. There's
Mm.
loads of famous people, Java champions there. I
Oh,
I have around 10-ish blog posts, the old ones, right? And
and how do you do to post there?
so you join the Slack, and then there is a channel there that you say I want to be a contributor. They give you a user, and then you write, and then they review it, and if they like it, it's there. There is no, they just put you in a queue, right? There is loads of people, but
Okay.
normally less than a week. So if you say I'm good to go, in less than a week is going to be published.
Okay, so they will review it. If it looks good, they just approve
Yeah.
it.
Anyway, they don't care about if it should be Java content, right? They don't care about like
Sure.
should be really polished. Really, no, it's more about write whatever you want. Of course, it's Java based, right? Then it's okay.
That's awesome.
Amazing. Also a good tip. So for those who want to maybe learn and share, this is a good place to go.
Absolutely.
Okay, so again, thank you all.
Thank you,
Thank
guys.
you, guys.
Thank
Thank
you.
you,
Thank
Igor.
you.
Thank you, everyone. See you tomorrow on TDC. Bye bye.
See you. Bye.